Due to growing concerns with the viability of fossil fuels as a long-term power source, many alternative energy sources have been growing in use throughout the world. One such alternative energy source is wind power. Wind is an attractive source of power because it creates a significantly smaller amount of greenhouse gases per unit energy produced compared to other sources. Once a windmill has been built, it can remain in use with minimal maintenance for over 25 years. Despite these advantages, wind energy produces a comparatively small amount of energy, and it needs to be as efficient as possible in producing energy to be cost effective. This project will examine the orientation of multiple windmills in a wind farm to find the most cost and energy efficient way to arrange them. There are multiple factors affecting the optimized orientation of wind turbines. First, it is desirable to fit as many windmills as possible in the wind farm. Forcing the windmills to be nearly touching, however, will not be ideal for producing power. One must also take into consideration the airflow hitting the blades of the windmills. Closely packing the windmills will not be effective if the windmills are blocking each other from the wind. Ideally, the windmills will be spaced perpendicular to the average wind direction. Orienting the windmills in the most optimal way is crucial for ensuring they are as cost-effective as possible. This will allow wind energy to become a more viable alternative energy source. The distance between the turbines needs to be optimized to improve their density without significantly impacting the amount of energy each windmill can produce. Fluid flow equations will be needed to understand how much the flow leaving one windmill affects the windmills next to it. This project will consider how a wind farm should orient its windmills with a given wind pattern. The constraint equations will be the amount of energy produced must be above a minimum value, and the windmills must not exceed a maximum distance between each other. The problem will view a 2D orientation of the windmill, and fluid dynamics equations will examine how wind is affected adjacent to and behind a wind turbine. A better knowledge of how to optimize wind turbine orientation would give better insight into where to place turbines. Areas once considered unfit for wind farms could find that they could install wind turbines in a cost-efficient manner. Furthermore, large open spaces would be able to generate more power at lower costs if they implement a more optimal turbine placement.